So I'll be talking about our company Excellent Renewable, which is located in Gujarat, and also in collaboration with Muniseva Ashram, which is an NGO. We have done quite a bit of work in the area of biogas production, generation from waste to energy. So my name is Hemant AVi. I'm a chemical engineer, worked in States many years, came to India for working for this NGO, Muniseva Ashram, and have been focusing my effort into this waste to energy. So this company, Excellent Renewable Private Limited, that is the company was formed all the way back into 1992. In the first 10 years, it was focused on solar hot water, solar cooking. In 2002, it went into biogas generation. And initially, it focused only on the KVIC domestic plants and KVIC model. Now, KVIC model that you have heard about, these are the ones that are very successful. They've been going on for last 50 years in Gujarat, and they've been, many of the plants, including the ones at Muniseva Ashram, have been running for the last 15, 20 years without any issues at all. They are floating dome plants. And we'll talk more about those plants later. Then we actually, taking the same KVIC design, we developed a community plant, community type of distribution network where the gas was actually distributed in the entire village. And one village was very successful, and that was also in Gujarat. And earlier today that we heard about the issues that we have with community plants, that is true. It's very difficult to get the community together to work on a collaborative fashion. But one plant that works in a town called Bitmudrak, and it works very well because the entire community is mainly made up of Christians. And the padri there, the father said that you are going to all help with this biogas venture, and they've been helping out, and it's been working very successfully. Except the last time I went there 2 years back, a year and a half back, and I asked them, how is the plant working? And they said that out of the 70, 80 people, villagers who have been getting the gas, now half of them don't want to give their cow dung to the plant. And I said, why? And what really happened is the government subsidy. Government last year came out, a year and a half ago, came out with a subsidy that the people below poverty level would get 1 cylinder of LPG cylinder for like 340 rupees. And they can get 1 cylinder per month. So if they can get a cylinder of LPG cylinder for that cheaply, why do they really want to bother about doing all this work? So it's very shameful, very interesting that how the dynamics work, where on one hand, government is trying to help the people below who are actually needing the help. On the other hand, that is really killing their collaborative cooperation to help out a plant like that. Moving on to the large community plants, we have added piping, pressurizing. What we do is we pressurize these biogas so that it can go a very long distance, up to 2-3 kilometers, and it can supply to not only for cooking but also for using the heat for boilers and furnaces. There was a new technology that we added, and that was a MUASB, that is a modified upflow anaerobic sludge blanket digester. And we have an example of that we have implemented, and that works very well also. And we'll talk a little bit more about when I show you the slide on that one. After that, we've actually collaborated with German partners, and we have implemented continuous stir tank reactors, where these are large digesters going up to, they can go from 600 cubic meter and up to 1,000 cubic meter. They can go up to 10,000 cubic meter digesters also. We have built 600 and 1,000 cubic meter digesters there. So the value proposition for the typical client needs, if it is going to be used only for cooking fuel, then it's a very simple solution. It's relatively simple. The cost here can be 5 to 12 lakhs. Now we have in the previous presentations, you have heard about different cost, the numbers. So let me tell you that in Gujarat government, they have a very successful subsidy program where the government through MNRE, they are to the Gaushalas, they are giving 75% subsidy. And for private companies, they are giving 50% subsidy. There, to give you an idea about the cost of these, the L1 rates that the Gujarat government has set up for the smallest size being 25 cubic meter, that goes for about 6.5 to 7 lakh rupees. Complete digester with the piping and the burner, everything. The largest one is 85 cubic meter. And the 85 cubic meter goes about 13.5 to 14 lakh rupees, Indian rupees. So that gives you an idea that the price, the cost that we are talking about, they are about in the same ballpark. And these are the floating design, so that has its own gas storage volume included. The heating fuel, where the biogas is used for heating fuel, is typically used where there is a factory where they have ETP plant, and that is already generating biogas, and that is being, actually many places that's being flared. This type of places, it's very easily that can be used, and it can be used for industrial purpose for in the boilers or for furnaces. We have actually implementation at Parle factory in Nimrana, where of course Parle make glucose and many type of food products, beverages. They have very large amount of 7 to 800 cubic meter of biogas that was being flared. And the management feeling very sorry that they are, I mean, it's really, they have so much fuel and that they're flaring. At the same time, they have boilers, and to run the boilers, they've been using until now LPG, or actually furnace oil, and now they are converting to the pipe biogas, PBG. Now we have working with Thermex, they have provided dual fuel burners, so that can take two different fuels at the same time. So depending on what is available, it can really do that job. So these are the heating fuel solutions. Power generation, also we have heard from many of the speakers today that it's very easy to generate power from biogas. It does not require a lot of effort and work to generate electricity. The only thing is that in India, the pricing is such that using biogas for generating power is actually, the payback works out to be longer because power is so cheap, relatively cheap compared to the CNG or pipe natural gas, PNG. So amount of raw biogas that you have, that really determines the ideal solution, what you really want to do. Of course, how you want to be using your biogas, it's important to you. But if you have a, let's say, 50, 100 cubic meter of biogas, then ideally it can be used for cooking for several. If you have 85 cubic meter, it's actually cooking for several families, not one family. Going on to 100 to 500 cubic meter, it can be used for power generation, it can be used for heating, and beyond 500 or 1,000, we can think about bottling, where it becomes economically feasible and viable. Now, today I think there was a question about bottling. When you have large quantity of biogas, bottling is a possibility, but at the same time, it has its own issues that I'll talk about a little later. So our company that has several product range, starting from family size biodigester, which is only 4 cubic meter, made from molded plastic boxes, to large institutional biodigesters that can be 1,000 cubic meter or larger, made from RCC tanks, complete with heating solutions and agitation. So I'm now going to show you a few slides where the actual implementation that we have to give you different ideas and different ways it can be, you can use biogas. So here, this is at a Sumul dairy where they were flaring these biogas. And so rather than flaring, what we did was we put the biogas, we stored that into a balloon, and used from the balloon, we provided a pressurized system, pressurized tank, and through that we are supplying to continuous supply to their furnace or their boiler. And the payback is less than 12 months, because here you're really basically not building a biodigester, because all you are providing is the storage solution and the distribution system. The bottling solution, there was a plant, several plant that I'm going to talk about. This one is a 600 cubic meter plant, 1,000 cubic meter plant, and 600 cubic meter plant. All these plants are based on cow dung and agricultural material, and they produce biogas, which is used for, which is then purified, and then it is bottled in cylinders. Now, there is, I'm going to go talk more detail about that a little later. Cooking and bottling solution at Waghodia in Vadodara, and this is a plant. Actually, this is not a plant, but this is it's a blueprint that is being developed. This is going to be a very large plant, 13,000 cubic meter and higher, and it's going to be taking 100 to 130 tons of mixed feed of pressed mud, the cow dung, the poultry litter, the agricultural material like maize silaging. It's going to silage that, and it's going to have mixed feed feed going into this plant, and it be generating up to 13,000 cubic meter of gas per day. That will be used for, that will be purified, bottled, and also converted to electricity. There is a plant we have at TCS Pune. This is based on kitchen waste only, and we have heard from several of the speakers that when you have kitchen waste only, there is you have to be very careful about monitoring the pH, monitoring the scum formation, and if you don't do that very well, then there is a chance of the entire digester going acidic. And actually, that we experienced that here in this particular plant, that the plant did go acidic, and it does require a lot of effort and a lot of cleanup once it goes acidic to bring it back to functioning stage. Oh, this is the community plant that I talked about at Bet Mudrak, and it provides, there are 2 digesters of 85 cubic meter each, so total 170 cubic meter digesters, and it generated, it used 4 tons of cow dung that was collected from all the villagers, and the villagers, all the villagers were given the biogas 2 hours per day free of charge in exchange for the cow dung that they are providing. But also they were paid some amount of money for the cow dung that they provided. The slurry that came out from here was actually converted through vermicomposting, and that today they sell that vermicompost at 4 rupees per kilogram, or 40 rupees 4 rupees per kilogram, or 400 rupees for 100 kilogram, or 40 kilogram bag for 160 rupees per 40 kilogram bags, and they are selling that to the municipality of Surat, so that's what is really helping generate revenue for this community-based biogas plant. Now I have a few more slides about the plant at Bakrol, which is the Munisio Ashram in Baroda. And actually this is the implementation where the first time in India where the biogas, raw biogas, was actually purified using a water scrubber system to remove the carbon dioxide, and then it was then compressed. This plant was running since 2009-10. And in about 2011, then MNRE held a conference there, invited a lot of people from all over India. So there were like 250 participants came to Munisio Ashram to learn this scrubbing and compression technology. So I'll talk a bit more about that here. So this particular system today we have is made up of a MUSAB plant that I told you. So MUSAB plant is basically it's a sludge blanket reactor. It's a passive system, but it automatically, passively, then provides some circulation of the gases within the digester, and that's how it can, it provides that mixing and minimizes the foam scum formation. It does have a scum breaker that periodically, once a day it's run and it breaks the scum. This is a mixed feed plant, so it takes kitchen waste, it takes cow dung, it takes press mud, it takes chicken litter, and it takes agricultural material also. Cow dung is approximately 50 to 60%, and the rest of them, the other 40% is made up from the other ingredients, other substrates. Along with this, what we did was we have other two 85 cubic meter digesters. So we combined the two of them in 2 kVICs in parallel in series with this 200 cubic meter digester. So the 3 of them work very well, and they are generating. They've been running for the last since 2002. They've been running since 2010. We've been generating electricity. So. This is the MUACB digester. It's a multiple feedstock that I mentioned to you. The solid concentration, it can handle all the way from 0.1 to 10%. Typically, we stay into the 7 to 10% range. It does provide high retention time and a low hydraulic time because of the volume and how it provides the internal also scum formation and scum breaking that is provided. And there is partial recycling of the slurry that happens because of the passive airflow. That's how it is designed inside. So the low pressure water scrubbing technique that we actually pioneered back in 2009, and that was running until last year. So this particular technique works well. It worked well, but it has severe limitations. And the biggest limitation here it is that the sizing. The plant that you are going to, you can design, you cannot go much higher because what really happens is when you're scrubbing with water, then you also have to remove the moisture that is in that, the purified gas. If you don't remove the moisture, then the moisture along with carbon dioxide and some remnant H2S that is always going to form acid when it is compressed. At low pressure, it's not an issue. But as soon as you go above 1020 bar, which you need to compress, it's going to form some acid, and that's what it's going to start corroding your compressor and also the cascade system. Actually, that's what we were using, a diaphragm pump. So we didn't have that issue because diaphragm is basically, there is a diaphragm in compression. So we didn't have that issue. And we ran that for next 3-4 years, but we did see continuous problem with the needle valve on our cylinders, and we had to continually replace them because they were getting eaten up by or corroded by the H2S and CO2 under high pressure and in the presence of moisture. Now, if your gas is absolutely dry, then you won't have a problem. But getting very dry gas is also, then you have to put either a refrigeration or a dehumidifying system. Let me move on to the next improvement that we did was we put up a pressure sink absorption system. So in order to get over this water scrubbing that had its limitations, and if you want to go to anything more than 600-700 cubic meter per day of biogas purification and compression, you're going to run into that problem with either a low pressure water scrubber or a medium pressure water scrubber. You will get into that problem. So we put up a pressure swing absorption system. This is made based on molecular sieve, and it goes through a cycle. And so for a few seconds, like 30 seconds, one cylinder is actually filtering the CO2 out, and the methane is being purified, and then it goes into the compression. And for the next 30 seconds, it goes into the second cylinder, whereas the first cylinder then is regenerating or removing the carbon dioxide that has been trapped. So actually there is another potential benefit of this particular system being able to let you remove both methane and CO2. And methane, of course, is going to be a fuel, but even CO2 can have commercial value that it can be used for beverages, and if you can find the market for that, you'll have a dual product here. So this is we've been running this for about a year now, very successfully, very low maintenance, and it functions very well. It's a very good technology, and I strongly recommend that if you're considering purification and compression, you should consider this PSA technique. This is the cylinder cascade system that is being readied for, and the cylinders are being filled up for transportation. At Muniseva Ashram, we transport it about 18-20 kilometers where our kitchen is, where then we use it for cooking. Again, if your kitchen is nearby, our recommendation is that don't go into compression, just use pipe gas, and you can very easily go up to 2-3 kilometers, and you can stay up to 2 bar pressure, and that can be easily, 1.5-2 bars can easily be more than enough what you need. We also tried vehicle filling, although in India it's not actually using biogas for vehicle filling. It's not allowed, but we have tested it out and it can work because there is absolutely essentially no difference between the refined biogas versus the CNG or compressed natural gas that we use for filling our vehicles. So work in Nepal, I've been working with a couple of actually the companies here who are interested in setting up biogas-based plants. Vajra Eco Resort in Tatupan in up north border, pretty close to the border with China. They're very interested in setting up it's an eco resort. So they are setting it up as an eco resort, and they are very interested in setting it up so that it can consume the kitchen waste that is generated there. But not only that, they want to actually use the kitchen waste that is generated from the entire village. There are more than 100 hotels in the village, and they would be collecting the kitchen waste because today they are dumping all of that into the village and into the river. So they would be collecting all of that. Also the cow dung, they would have several cows and animals, and all their droppings would be used for generating the biogas. The products would be, they are right now considering street lighting or also cooking gas for several, for the resort itself, but also the villagers there. So in addition to that, the organic fertilizer that would be used for their premises as natural organic fertilizer rather than using inorganic fertilizer. I'm also working with another company, Gold Rush. They are in the process of building up a municipal waste-based waste-to-energy plant, and they are actually putting together their proposal to get the funding and convincing, working with the municipality there at Pokhara. We have Pooja and Prem here who are from that company. In addition to this municipal waste, they have a couple other actually institutional biogas opportunities. And here, these are at the barracks, a couple of barracks, and where they want to use not only the night soil, but also the kitchen waste that is generated in the barrack. And in addition to that, the slurry which it comes out, they want to use the slurry to mix with shredded dry material, vegetation, like the leaves, the green leaves, the grass, chopped up grass, and then use all of that for vermicomposting. So that's a very interesting idea that we have there, because I think today we heard from one of the speakers that the beauty of the slurry is only about 8% solid and 92% is liquid. If you can add that with other dry material, and then use that for vermicomposting, because the uptake of that slurry by it's absorbed by the dry material, and then it's a great food material for the earthworms to convert that into vermicomposting. So this combining these different technologies, really we need to really think about where we can generate more value out of the waste. Okay, so what we can offer. We have actually an open invitation to our sites and at the Muniseva Ashram. So Pooja and Prem, they really took up this opportunity. They came down to they came to Baroda, visited the Muniseva Ashram, and it was great for them to see the plant firsthand, what we've been doing there. So if anybody is interested in exploring whether you want to go with us or just build it on your own, it's just learning opportunity. So I welcome anybody who wants to come there and learn from that experience. What we can do is that I believe that the technology transfer has to happen, and The contractors or the providers here in Nepal, they need to be enabled, empowered to implement this in due time. So what we can do is, and this is not going to take a lot of effort and a lot of work, maybe 1 or 2 designs implementation they can do on their own, and they would be able to stand on their feet and then do this type of work on their own. What initially for the 1 or 2 plants, what we can do is all these things we can do. We can develop the conceptual plan, we can do the consultation, we can help them develop the whole FDPR, the proposal detailed design, so that they can first of all convince their customer, and secondly they take it up to the bank for getting the funding. So prepare the detailed plan design, prepare the FDPRs. The structural design is very important. What I've heard is that many of the plants, if they are not properly designed, civil design is not done properly, then they start leaking. So the civil design is very important. As soon as you start building plants above ground, the footing becomes very critical, and also the RCC structure, the walls, the wall thickness, all those things become very important and critical. The underground plants, when we build them under the ground, it's less important, because now you think about that, there is pressure from outside equalizing pressure from inside, so the leakage is not really a great problem. So all the KVIC plants that Gujarat government is allowing are all made from brick, and they all work perfectly fine. So anyway, detailed structural design, providing the detailed bill of material. So the bill of material would state basically what the cost would be if it is done in India, and our Nepali counterpart, they would go through each of these item by item and say that how much that would be, what the differential would be in Nepal. And so they would actually put the whole proposal together, and they can take that to their customer and then present it based on for the Nepali environment and Nepali labor actually, because we being in India, we won't have great information. We won't know about how to really work with the workforce here, actually hire the workforce, and we would depend on our Nepali partner to do all that. When it is actually time to do the civil work, we would provide a supervisor and project manager, and that would be the time when a lot of technology transfer would happen. Our project manager or supervisor would work with our local partners counterpart, and that's when they'll talk and they'll describe and how the whole civil work is done and built. And finally, commissioning start when training is also a great opportunity where a lot of this technology transfer does happen. And the idea is, of course, to not only to build the plant, but to keep it going and sustain it for the long term. So that's the end of my
Thank you. Thank
presentation.
you very much.
Thank you.